Hi, good morning. I started with a pretty heady title for today's keynote, The Future of VMware Virtualization, but actually yesterday Maurizio gave it a great title. I thought I'd talk about technical stuff. So, looking forward to a presentation today. Yesterday Paul presented a pretty aggressive vision for how we plan to transform IT from the data center to the client and into the cloud. And today the goal is to really back that up with specific features and a set of demos that I think you'll enjoy that really show how we're going to make it true in 2009 and beyond. I also have the very distinct pleasure of presenting this here, as a large number of the features we'll discuss have been developed by our European engineers. We have 5 offices here and several hundred research and development folks who've been working hard to bring these to reality. So we have a fun-filled hour here. Let's get started pretty quickly. As Paul talked about, vSphere is our first implementation of a virtual data center operating system. It consists of multiple layers. And thinking about it as a traditional operating system, it has 2 functions. One is that it controls hardware, and the second is that it provides a set of interfaces to applications. And if you kind of think about it a little bit differently, instead of a single piece of server hardware that it's managing a whole data center, a collection of your storage arrays and your networking and your servers. And instead of running applications that have been written specifically to its interfaces, it's running virtual machines, and those happen to incorporate their own operating system. And it's running a lot of them at the same time. So that's why we think about it as an operating system. It has very many benefits beyond that, of course. The first of which I wanted to go into was how it aggregates the underlying hardware and brings the best out of it. So let's talk about this first layer of the vSphere offerings. First of all is how powerful can these virtual machines be? I think people have thought about virtual machines as these lightweight, kind of cute things that you run smaller applications in. But my goal today is to prove that they're not just cute, they're actually very, very powerful. So in the earlier releases, this is the size of a standard virtual machine, the application, if you will, in the virtual data center operating system. And if you fast forward to today's VI 3.5 product, we've gotten this thing to be pretty powerful, 100,000 IOPS, 4 virtual processors. But in the vSphere generation, we'll be raising this to quite a new level. So it'll be able to support 8 virtual processors, quite a bit of memory per virtual machine. And what's particularly exciting is the I/O bandwidth, and this is what's so important for running the highest-end applications. So let's dive right into that. One of the first exciting announcements is some early look at what we're going to have on the performance front. A lot of people are worried about running the highest-end databases, but as a result of looking at what we're doing on this particularly interesting workload, I think you're going to feel differently. So this is running on a great next-generation Intel part, using Linux and Oracle 11G, running on our in-house ESX server. This is a few things you should take away from this very high-end OLTP workload. First of all, this is less than 15% overhead on an 8-way system, running an 8-way virtual machine. So a single machine running extremely well. And if you're into the numbers side of databases, this is doing 24,000 total database transactions every second. And what's also very interesting, Oracle's done a very good job, unlike a lot of software, in scaling so that it itself can take advantage of a large number of CPUs. And VMware is right along with it. We're able to scale quite well as we go from 1 to 4 and 8. But last thing that's pretty fascinating, if you're really into the I/O side of the world, we do 250 megabytes per second of I/O here. And I was asking our guys what this really means. It took us over 510 disk spindles to saturate what this single virtual machine can drive. And so I asked them for a picture. I thought you might enjoy this. That's actually what 510 disk drives look like. And you can't exactly see the virtual machine, so I put an arrow. It's right there. So this is just a massive amount of I/O that we're driving from one single virtual machine. I also had a colleague tell me that this is pretty amazing. He had joined me from Sun, and he said they had achieved a similar transaction rate a few years ago with a very high-end piece of hardware. This cost several $1 million just in 2002, running 48 UltraSpark 3 CPUs. So the message to walk away with here is that there's simply incredible power coming out of an individual VM. No excuses not to run your databases now. We still think it's cute though. Okay, so let's move on to the next thing. That was a case where we showed that a single virtual machine can be very powerful. Another interesting thing that we launched actually in this event last year was IBM coming on stage and talking about a world record performance running Exchange. And this was a different case. They had run a native implementation of Exchange on a nice system and got 8,000 mailboxes. But it's very hard to scale software up to the large number of cores that are available today. And so what they recognized is if you break up Exchange and run several copies, each of which has a smaller number of CPUs assigned to it, the aggregate throughput of that system can be substantially better. And this is a really important point to walk away with because cores are coming, more and more cores per system, and very few applications can take advantage of them natively. We think about applications as not scaling as well, but when you run them in VMware, you can take advantage of all of those. So we've just announced another world record to follow up on the Exchange one, and this is on an industry standard SpecWeb 2005 benchmark. This is focused on what a web server has to do in the real world. And this is very exciting for us too, because some people also think that you can't run big web farms and big web servers directly on virtualization when you're in full production. From a performance standpoint, hopefully this will dispel that myth. What you can see on the left side here is the official spec benchmark page that comes from that organization. And if you zoom in a little bit, you'll see the first entry that's there from VMware running on some nice HP hardware. We've achieved 44,000 as our score, and this is on 16 cores. This is the aggregate high score that has been achieved on 16 cores. Again, showing that when you break up the workload into multiple virtual machines, the aggregate capabilities that you have are quite strong. Now, putting this in perspective again, I don't have the picture of the disks in this case, but this is something that we're doing that has 16 gigabits per second of web traffic on the support side of it, 143,000 HTTP ops per second. But what it really means is this particular implementation would serve 3 billion pages per day of web traffic. And I was just searching around the internet to see what that relates to, and this is from the founder of eBay. On a typical day, there are about 1 billion page views on eBay. So there's a lot of other details behind this that you'll need as you go forward and run your highest end web workloads. But from a sheer performance standpoint, the ability to carve up virtual machines and take advantage of all the great hardware that's there is here to stay. So moving on to that next layer of this virtual data center operating system is the storage side. And we've always been working on storage for quite a long time. And our goal here is to pair up the amount of differentiation and exciting features that are coming in with arrays, but have them fit into a nice framework that makes it very easy to manage, which is really one of the key goals of our overall virtualization solution. Paul yesterday mentioned that we could take advantage of things like block copy or disk deduplication technologies that are coming out. One other one that we're very excited about in the vSphere offerings will be thin provisioning. So in this case, it's a little bit different. This is a case where you have a number of disks that on the aggregate add up to a lot more storage than you physically own. And this is a good example of how we see these storage APIs working out. We have a software implementation of thin provisioning that will be part of the product, but we also enable array vendors to write plugins so that if they have their own implementations of thin provisioning built right into the arrays, which are typically higher performance and have other capabilities, they can fit right in here. And it's not just about taking advantage of the underlying capability, you have to be able to manage it as well. In fact, it's extremely important in thin provisioning. You need to know when the equivalent of a bank run is happening, when everyone all of a sudden wants their real storage, and that needs to plug right into the system. So part of this plugin is to fit right into the alert system so that you can take action. I like Dr. Tripp's analogy yesterday of the airline industry. When you have a lot of people who want their physical storage, that's the equivalent of when airlines get on the intercom and say that they need volunteers to give up their seat. So that's what we have to do here. So a lot of other things going in storage, but I wanted to shift to networking quickly. We've had a huge ramp in focus with our partners and internally on networking, and it obviously is one of the key parts of the overall data center. So we've done a bunch of different things. Looking at today's world, we have a virtual switch that is part of every ESX server that you have, and you log into your ESX server, and you configure the network with various settings. The problem with this is twofold. One is you have to remember to set all of the different switches the same if you want them to behave the same way. And secondly, as we get to more advanced network functionality, the state that goes along with a virtual machine needs to be transported as it goes around. Today, if you have a particular network state, think of it as statistics about how your network is doing, and you vMotion to another server, you will lose that state. So an exciting part of vSphere is what we call the distributed switch. And in this case, think about it as aggregating all of your network capabilities around your servers together. And you have one switch that spans all of the different hardware that you have in place. Two things follow from this. One is you configure it once, and everything in your data center takes those settings. And secondly, we can now maintain state, network-related state, of the virtual machine as you move around. You'll see more why this is important in just a moment. And the other part of the network side, just like on the storage side, is to be able to take advantage of our partners and the capabilities that they have. So one of the more exciting announcements that we've had lately has been about switch plugins in this case. And on the vSphere extensibility front, Cisco has developed a virtual switch that plugs directly into vSphere. And you get a lot of very good goals out of this. One, network administrators will get the visibility that they're used to from working with their own Cisco switches. This is very important that today they see up to the server level, and because we have a large number of virtual machines